So this is a gate question related to analog electronics, operational amplifier circuits. So let's see how to solve the problem. The operational amplifier has an input offset voltage of 1 millivolt, and the ideal case, if the op amp is used in the circuit as shown in figure, what will be the output voltage? The options for this question is 1 millivolt, 2 volts, C is plus or minus 1 volt, and D is 0 volts. So this is the circuit. So before going to solve the problem, if you know the basics related to operational amplifier, as we know that the function of differential amplifier is to amplify the difference between the two signals. So the output voltage is V0 AOL times difference between the input voltages. Okay, so here you are not applying any input voltages, so the output voltage should be 0. But practically, ideal case V0 equal to 0. So you are not applying any input voltage at these two terminals, that's inverting terminal as well as non-inverting terminal. So from the general equation, V0 should be 0. But practically V0 is not equal to 0. Why? Because due to internal operational amplifier, differential amplifier stages and practical imbalance in the internal circuitry of the operational amplifier, so ideally the output voltage should not be 0. To ensure that for the output voltage should be 0, we have to balancing some amount of input offset voltage you are applying. So that voltage we can call it as input offset voltage. Input offset voltage means the amount of DC voltage applied at the input to get 0 output, that is V0 equal to 0. So the input offset voltage is indicated with VIO. So VIO is the magnitude of difference between the two voltages. V plus is non-inverting voltage, V minus is inverting voltage. So either it is positive or negative, since we are going with the magnitude terms. But what are the golden rules for ideal operational amplifier is input resistance is infinity. So the amount of input current entering into the operational amplifier is 0. But due to this loop, some amount of current is flowing through feedback resistance and this resistance. But if you see the circuit, V plus is 0. But due to practical imbalance of the internal operational amplifier circuitry, some amount of output voltage appeared. So due to that, some amount of current is flowing in this loop. So now apply voltage divider rule to find out the inverting voltage. So V minus, that is inverting voltage, equal to R1 by R1 plus RF into V0. So simplify that, output voltage V0 equal to 1 plus RF by R1 into V minus, inverting voltage. So V0 equal to 1 plus, what is feedback resistance here? 1 mega ohm. What is R1? 1 kilo ohm. You substitute the values here, 1 mega ohm by 1 kilo ohm into V minus. So V0 equal to 1 plus 1000 into V non-inverting voltage. So 1 is very much less than this 1000. So approximately this is 1000. So if you know the input offset voltage difference formula, so V plus is 0 and V minus is 1 millivolt. So since we are considering it's a magnitude term, so VIO, input offset voltage, is 0 minus V in. So V input voltage is approximately equal to V minus, that is plus or minus 1 volt. So you can substitute the 1 millivolt here. So you are always considering the magnitude term, that is plus or minus 1 millivolt. So V0 equal to plus or minus 1 millivolts. The right option for this question is C, plus or minus 1 volt. The output for input offset voltage, the right option for this question is plus or minus 1 volt. Thank you.